Hello everyone, here we are going to continue with exercise 13.2 of the chapter Understanding Quadrilaterals. We have already did till question number 5 in our previous video. Now we are going to do question number 6. Here in first part of question number 6 we are having this figure in which we have been given with this angle 40 degree, this one as 70 degree, and we have to find the value of x, y and z. Now as we know this is a parallelogram, so all the opposite sides are parallel to each other. Therefore, this y will be equals to this 40 by interior alternate angles. So y equals to 40 degree interior alternate angles. And in triangle PHO, here this is an exterior angle and these two are interior opposite angles. So the sum of these two will be equals to 70. And here we get x plus z equals to 70 by exterior angle property of triangle. Now we can place the value of y over here, and this will be 40 plus z equals to 70. So z equals to 70 minus 40, that is z equals to 30 degree. Now we see that this x and these two angles, that is angle PEH and angle OHE, they both are co-interior angles. So the sum of both the angles will be 180 degree. Therefore, the sum of angle PEH and OHE equals to 180 degree by co-interior angles. Now we can place the value of PEH by x and OHE will be 40 plus z equals to 180 degree. Now we know the value of z, that is 30. So x plus 40 plus 30 equals to 180 degree. Now we can do the transposition from here, and this will become x equals to 180 degree minus the sum of these two, that is 70. And here we get x equals to 110 degree as answer. Now let's move to the second part of the question number 6. Here we are having this figure which is a parallelogram ROPE. Then here we have to find the value of x, y and z, and we have been given with this angle as 60 degree and this one as 80 degree. Here this line is parallel to this one and this will be parallel to this. Now as this line is parallel to this, so y will be equals to 80 degree as interior alternate angles. So y equals to 80 degree as interior alternate angle. Then as we see that all the three angles are on a straight line, so the sum of all these three angles will be 180 degree as the angles on a straight line. So x plus 60 plus 80 equals to 180 degree as angles on a straight line. Now solving this, x will be equals to 180 degree minus the sum of these two, that is 140, and here we get the value of x as 40 degree. Now this z will be equals to x as interior alternate angles. Therefore z equals to x as interior alternate angles, and we get the value of z as 40 degree as answer. Now let's move to the first part of the question number 7. Here we are having a parallelogram TURN turn, in which these are opposite sides, and here this 5y minus 1 will be equals to 24 and 4x plus 2 will be equals to 28 as opposite sides of parallelogram. So here TU equals to NR as opposite sides of parallelogram. So this side is equals to this one. So we can write this one as 4x plus 2 equals to 28. That is 4x equals to 28 minus 2, which will be equals to 26. So x will be equals to 26 upon 4, and on our solving this will be 13 upon 2. So we get x equals to 6.5 centimeter as answer. Also we have this side Tn equals to UR, so we can equate 5y minus 1 equals to 24. So on doing so we get 5y minus 1 equals to 24. So this can be written as 5y equals to 24 plus 1, that will be 25. Now y equals to 25 by 5, that implies y equals to 5 centimeter as answer. Now let's see question number 7, second part. Here again we are having a parallelogram, and as we know the diagonals of the parallelogram bisects each other. This means this portion will be equals to this one and this will be equals to this. So very first of all we can equate x plus 3 by 18, and on doing so we get x plus 3 equals to 18 as the diagonals of parallelogram bisects each other. And on making a transpose, this will be 18 minus 3, that is x equals to 15 as answer. That is 15 centimeter. Now we can place the value of this x by equating x plus y by 20. And on doing so, we get x plus y equals to 20 as the diagonals of parallelogram bisects each other. Now we are going to place the value of x over here. So this will be 15 plus y equals to 20. So y equals to 20 minus 15, and hence we get y equals to 5 centimeter as answer. Now let's move to question number 8. Here we are having this figure. In this figure we are having two parallelograms A, B, C, D and P, Q, R, S. And these two parallelograms are combined to each other. Now we have to find the value of this x. Now to find this value, very first of all, let point this intersection by O, and then we see that this angle and this angle in the parallelogram ABCD, they both are co-interior angles. So let name this one as A, and this angle and this angle, they both are opposite angles of a parallelogram PQRS. Let name this one by B. So very first of all, in parallelogram ABCD, the sum of this angle and this angle will be 180 degree as co-interior angles. And here we get 120 plus A equals to 180 degree by co-interior angles. We can also write adjacent angles of parallelogram in place of this one. Now we can make a transpose to get the value of A, and A will be equals to 180 degree minus 120 degree. That is A equals to 60 degree. Then after that, we know that this B will be equals to 50 degree as opposite angles of a parallelogram PQRS. So in parallelogram PQRS, we get B equals to 50 degree as opposite angles of parallelogram. Now we have this triangle PBO. In this triangle, we know the angle A, we know the angle B, and we have to find this angle X. So we can use angle sum property of triangle. And here we get x plus a plus b equals to 180 degree by angle sum property of triangle. Now we can place the value of a and b. So it will be x plus a we have 60 plus b we have 50 equals to 180 degree. Now on making a transpose, this will be x equals to 180 degree minus the sum of these two, that is 110. And therefore x will be equals to 70 degree as answer. Now let's move to question number 9. Here we are having a parallelogram ABCD in which we have to find the angle of CAD, ACD and ADC. And we have been given with the angle AOD, angle CDB and angle CBD. Very first of all, we can find out this angle as angle ADB, which is equals to angle CBD as interior alternate angles. Here we have angle ADB equals to angle CDB as interior alternate angle, which is equals to 46 degree. Now with the help of this angle and this angle, we can find out the value of angle ADC. Therefore, angle ADC equals to angle ADB plus angle CDB. And here we have ADB as 46 and CDB we are having 30. So that is equals to 76 degree as the value of angle ADC. Now with the help of this angle, we can find out this angle as we are having this angle and this one. So by angle sum property in triangle AOD we have, and here in triangle AOD we have angle ADO plus AOD plus OAD equals to 180 degree by angle sum property of triangle. So ADO we have just calculated, and this is 46 degree plus AOD we have 68 and OAD we have to calculate equals to 180 degree. Therefore angle OAD equals to 180 degree minus the sum of these two, 114, and we get OAD equals to 66 degree. That can also be written as CAD equals to 66 degree. So angle CAD equals to 66 degree. Then we have to find out the angle ACD. So in triangle ACD, we have angle ACD plus CDA plus ACD equals to 180 degree by angle sum property of triangle. Now ACD we have to calculate plus CAD we have just calculated 66 degree. CAD we have got over here as 76 degree. Then we are going to make a transpose of these two on the other side, and we get angle ACD equals to 180 minus 142. That is angle ACD equals to 38 degree as answer. Now let's see question number 10. Here we are having a parallelogram ABCD in which AC is diagonal and two perpendiculars have been drawn from D as DA and B as BP. Now we have to prove the triangle DCN is congruent to triangle BAP and AN is equals to CP. Now very first of all we are going to prove these two triangles congruent. So in triangle DCN and BAP, we can take DC equals to BA as opposite sides of parallelogram. Then this angle is equals to this one as 90 degree each. And after that, we can take this angle equals to this one as interior alternate angles. Let's name this angle as 1 and this one as 2. So here we get angle 1 and angle 2. So angle 1 equals to angle 2 as interior alternate angles. Now to prove these two triangles congruent, we have used this angle, and this side. So it is AAS. Therefore we have got triangle DCN is congruent to triangle BAP by AAS congruency criteria. Now we have to prove that AN equals to CP. For that, we see that AN and CP both are not a part of our triangle which we have proved. So very first of all, we are going to prove that CN equals to AP. And here we have proved CN equals to AP by CPCT. Now we see that in CN we are having two parts, CP and PN. And similarly in AP also we are having two parts, AN and NP. And we have got CP plus NP equals to AN plus NP. Now we can cancel out NP from both of the side and we're left with CP equals to AN. Hence proved. Now let's move to question number 11. Here in this question we have a triangle ABC and a line parallel to AB is passing through C, a line parallel to AC is passing through B, and a line parallel to CV is passing through this one. Now from the figure, if we take a quadrilateral ABPC, we see that this side is parallel to this one and this is parallel to this one. So this can be a parallelogram. Now here in quadrilateral ABPC, AB is parallel to CP and AC is parallel to BP. Therefore, this quadrilateral ABPC is a parallelogram as both pair of opposite sides are parallel. Now as we have proved the ABPC is a parallelogram, we can prove ABC are also as a parallelogram. Similarly, ABCR is also a parallelogram. Now we know in a parallelogram opposite sides are of equal length. So this AB will be equals to CP and here we get AB equals to CP as opposite sides of parallelogram. Also this AB will be equals to CR as opposite sides of parallelogram. And here we get AB equals to CR as opposite sides of parallelogram. Now if we add both of the equation, then we get twice of AB equals to CP plus CR. That is twice of AB will be equals to CP plus CR. That is we can write this one as PR. Now as we have proved this twice of AB equals to PR, similarly we can prove this twice of BC equals to RQ and twice of AC equals to PQ. And after that, getting the twice of AB equals to PR, twice of BC equals to RQ and twice of AC equals to PQ. We can add all of this and on adding all of this we get twice of AB plus twice of BC plus twice of AC equals to PR plus RQ plus PQ. Now we can take two common from here and this will become twice of AB plus BC plus AC equals to PR plus RQ plus PQ. Hence proved. That's all from this video. Thank you.